Actually, we've got a couple minutes, so to let anybody who's online still coming, before we get started officially, does anybody have any math problems from any assignments or anything that they were wanting clarification or assistance with? We've got another one coming in. You just opening for notes, or did you have a question?
I don't have a question.
Okay. All right. Give them 1 minute. So the last time I was here, we talked about geometry. We talked about the angles of triangles adding up to 180. We talked about vertical angles and linear pairs being a straight line and also forming 180. We worked a little bit with the areas and how you can remember those areas by always going back to the rectangle. That's where we left off. For today, our two big ones are going to be the Pythagorean theorem and trigonometry. And so the Pythagorean theorem is the relationship for all right triangles that we can find the third side. And then trigonometry is using right triangles and similarity to apply to any right triangle. It's the general rule to be similar to any of them. So, the Pythagorean theorem, there are some things that we teach that it may be on the test. Pythagorean theorem will be on your ACT in probably at least 3 different problems, if not more, in some form. The Pythagorean theorem's always going to be there. And so, along the same lines, if there's ever a TV show or a movie and they want to show you are in math class, one of 2 things is going to be written on the blackboard in that TV show. One of them is y equals mx plus b, and the other one is a squared plus b squared equals c squared. That's the universal symbol for you are in a math class. So, yes.
Okay. Has everybody joined online?
Yes, I'm keeping an eye on it.
Only 4 of them, huh? 5, 4, 5?
Yeah, but lots of people in here.
Okay. And you're recording, right?
Yes.
Okay. Can you turn the iPad in so that people who are watching can clearly see it?
We're fighting.
Yeah, something like that.
There.
Okay. All right.
Okay. Can you see okay? All right. The camera can still see the board, even if I can't see the screen. So, a squared plus b squared equals c squared. The important part to know is, what is the c talking about?
The 2 other angles added up.
Not angles, but sides. But specifically, yes.
That refers to the hypotenuse.
The hypotenuse, or the longest side. The idea is that you're going to have 2 smaller pieces adding up to the biggest piece. And so the longest side, the longest distance, the biggest side, the hypotenuse, always has to be alone. This one has to be the biggest. Whereas A and B, especially because it's addition, they're completely interchangeable. I could use A for 3, or I could use A for 4. It doesn't matter on those 2. You just have to make sure that the long side hypotenuse is the one that's always by itself. And so in this case, I go in order that I see it and say 3 squared plus 4 squared. If I had put 4 squared plus 3 squared, would not change the answer at all. And I'd like you to get in the habit of just putting this entire chunk into your calculator. You don't have to calculate them out individually. Just type in 3 squared plus 4 squared. Does anybody need help finding squared on your calculator? You can go back to squared means multiplied by itself. And so if you don't know where the squared button is, you're doing 3 times 3 plus 4 times 4. That's what squared means. But in any case, you're going to end up with 9 plus 16 is 25. So, is 25 my answer? No. What do we need to do to finish it off? Yes? Find the square root of 25. In this case, it's a nice, pretty answer. Square and square root cancel out to leave just C, just the thing we were looking for. We're looking for that distance. And square root of 25, we don't have to consider the negative because we're talking about distance. Distances are always positive, so it's just 5. If possible, I would like you to remember these three numbers together. It's called a Pythagorean triple. 3, 4, 5 always works out to a nice, pretty right triangle with whole number sides. It's one of the oldest ones known, and the ACT likes it a lot. They're going to throw 3, 4, 5 at you in some form of example at least once per test. And so 3, 4, 5, it's a right triangle. It's a bit of a shortcut. 9 and 12, find the hypotenuse here. I have done the test without it. So, we have the square root of 81 plus 144, which added up to the square root of 225. What was the square root of 225? 15. This is just a variation of 3, 4, 5. Again, it's similar. 3 times 3 gives us 9, 4 times 3 gives us 12, 5 times 3 gives us 15. And it just shows up again. And so you'll also see variations of that number combination. On our next number, the common mistake that people make, and the one that they're going to offer up to you on a silver platter of multiple choice, is people want to go, oh, okay, 5 squared plus 13 squared equals my missing side squared. What's wrong with that?
13 is your biggest side.
Yeah, 13 is the biggest side. The biggest side always has to go alone. And so instead, go back to a squared plus b squared equals c squared. 13 has to go alone. And whether you put 5 in for a or b does not matter at all. I'm going to put it in for the first one. And so instead of 5 squared plus 13 squared, instead we need to be taking that 13 squared and subtracting 5 squared. We need to solve for the unknown. 13 squared is 169, I think. I don't have a calculator either. And we're subtracting 25, and we're left with 144 equals b squared. Ooh, we've seen that number before. What's the square root of 144? 12. And so this one, again, we're going to see it as well. That one's another Pythagorean triple. 5, 12, and 13 make nice, pretty whole number right triangles. And the ACT can be done without a calculator. It's a little bit slower, but a lot of the problems You don't have to have a calculator to get the correct answer. So, this one is not going to be a nice, pretty whole number. But I want you to get your answer as a square root. So using the 8 and 12, what is the length of our hypotenuse? And leave your answer as a square root. Because frequently the ACT is going to give you the exact answer options, not the decimal ones. What number are you getting? Yes. 208. So our answer is the square root of 208. Now the problem is that they might not look like that in the options that they give you of multiple choice. And there's this thing called simplifying roots. But there's a little bit of a shortcut. What divides 8 and 12? What's the common factor of both 8 and 12? 4. What is 4 squared?
16.
Take the 208 and divide it by 16. What other number are you getting? 15? 13. So, this square root of 208 can break up into the square root of 16 and the square root of 13. Now, we already talked about 4 being the perfect root of 16, right? And so this simplified, the square root of 16 is 4, and then the square root of 13 is left over. And so this is what you'll see as one of the multiple choice answers. That is a simplified root. And some of you might have brushed on that in Algebra 1, but you'll do it a whole lot more in Algebra 2. And so you'll work with that a lot. If, yes,
So how did we get
the 16.
in?
So 8 and 12 had the greatest common factor of 4. Sorry, handwriting's getting bad when I bend over this far. Greatest common factor was 4. And so you can divide out 4 squared from that root. Anytime they've got a factor in common, that's what's going to simplify out of that root. So the other thing you can do if you're just feeling like, I don't remember, I'm not feeling confident, let's say that you had the square root of 208 as your answer. Run that through the calculator. Take the square root of 208. What do you get as a decimal?
14.4.
And then you could take that 14.4 and run the multiple choice options through the calculator as well and see which one does it match 14.4. And so if you're not confident about those simplifications, you can do a workaround by taking your square root and comparing it to the options that they gave you. And so that's another technique to deal with. Hey, it's the test. I don't feel like dealing with simplifying roots right now. My brain is feeling frazzled. Punch it in the calculator and find the matching decimal. And so there's always a workaround. All right. Questions about the Pythagorean theorem. Pretty much what we're going to do today going forward is always Pythagorean theorem plus something else. So I want you to be really confident about this. Don't hesitate to say, hey, slow down and go back. All right. So one of the first places that you're going to deal with the Pythagorean theorem is a little bit of a cheat. What's going on is called special right triangles. And these special right triangles show up often enough that they have a pattern between them. So the first one is, if we have a square, a diagonal goes from corner to corner and crosses through the inside. And so if we have a square with a side length of 7, the question is, what is the diagonal of that square? Well, first of all, what makes a square? What do we know about its sides?
Dawson.
They're all the same. So if this is 7, so's this side up here, so's this side over here, so's this side over here. And so if we're talking about the diagonal of our square, in reality we're talking about this right triangle that has two sides that are 7 and 7. Now, what would the hypotenuse of that triangle be? My mental math being right, I'm getting the square root of 98. Is that right? Okay. But remember what I showed you back here. What's the greatest common factor between 7 and 7? 7. There's the same number. What was 7 squared again? 49. This 98 just came from having two 49s, right? That's how we ended up there. And so this is the square root. Square root of 49 is back to that 7, square root of 2. These special right triangles, again, they show up in Algebra 2 a little bit, pre-calc a lot. Whenever you get to unit circle, you're going to be using this particular triangle all over the place. But what happens is, it doesn't have to be 7. If I tell you that this is 9 sides on my square, this is going to be 9 square roots of 2. If I tell you that it's 280, it's going to be 280 square roots of 2. Whatever the side of this square is, it's going to be that times the square root of 2. And so that's what makes this a special right triangle. It's always the side length times the square root of 2. When you have what's called a 45, 45, 90 triangle, or half of a square. So really quick example with that. This is an actual ACT problem rather than background. In the figure below, xy equals xz. And here's our triangle. We have x, y, and z. We've got a right angle. We have angle A up here and a side length 5. But then it says if A equals 45, then YZ equals what? So there's a lot of background going on here, but it's actually a very simple problem.
Is it 10?
No,
10?
because that would be a straight line. 5 plus 5, 10. We still are treating this like a right triangle. So,
Is it 5 times the root of 2?
yes, it is 5 times the root of 2. It's going to follow that exact same pattern. 2 sides. The diagonal is just that side times the square root of 2. If you do not remember that, some of the background information that's going on is that this is 45, and if this is 90, this angle is also going to be 45. Anytime these angles are the same, the sides across from them are also the same, so this is 5. And if you don't remember the special pattern of side times the root of 2, you could still run that through the Pythagorean theorem to get the right answer. The special patterns are a bit of a shortcut, but they are not required in order to get the right answer. They just make it faster. All right. So, next one, just clearing out some clutter. Down here, we have an equilateral triangle or an equal-sided triangle. Anybody remember what the angles of an equilateral triangle are going to be? It's okay if you don't, just curious.
Aren't they like 60 each?
Yes, because again, equal angles means equal sides mean equal angles. If all three sides are the same, all three angles are going to be the same. And so we take that 180, chop it up into 3 equal pieces, and we get 60, 60, 60. Now, again, if the sides are all equal, if this one's 8, what are the other ones going to be? 8. But in regards to special right triangles, we're very much interested in half of this again. And so we're going to go from the top and cut this exactly in half. It's going to make a right angle, and it's going to chop this bottom side in half into 4 and 4. And it chops this upper angle in half into 30 and 30. And again, we're specifically interested in just half of it because we're looking at that missing side called the altitude or the height. So, is our hypotenuse the one that's missing? No. And so again, we're going to be setting up that 4 squared plus we don't know squared equals 8 squared. 8 squared is 64. Equals, we don't know squared, plus 16. Subtract the 16 from both sides. And we get 48. My brain, right? Okay. And again, we are square rooting both of those. This one, the square root goes away, that's what we wanted. And again, what could divide both 4 and 8? What's the common factor? 4. And so we're going to be taking this 48 and dividing it by 4 squared, or 16. What's left over is 3. And so we have 4 times the square root of 3. Again, this one is one of those special pattern ones. It doesn't care what this number is. We're going to call it M because I want to get away from X. Whatever that little piece is, this is always going to be double it because there were 2 of them, remember? In part of our triangle. And so this long hypotenuse side is 2 of them. And our other leg, our missing leg, is always the short side times the square root of 3. And so this is the other special relationship. It always happens with 30, 60, 90 triangles, that you have short side, hypotenuse is double that short side, and the in-between is the short side times the square root of 3. No matter what number you started with, it always follows that same pattern. So, again, problem that uses that relationship from this says that this is x and this is x times the square root of 3. And that this is 60, and 30. So, very simply, what is our hypotenuse going to be in terms of x? It's following the same pattern as the m down there. Yeah, 2x, that's it. Now, the follow-up is that they tell us that the perimeter equals 12 plus 4 square roots of 3. And the question is, what's the value of x? And so it's going to, yeah? 4. This is easier than you think, because what you're going to do is take x plus 2x gives us 3x, plus x square root of 3, plus x square root of 3. And we're playing match the pieces. X and 4, 12 is 3 times 4. And so it's a weird way to present it, but not hard. All right. Timing-wise, I want to move on to... We're going to do one more Pythagorean theorem problem, and then we're going to work on trig for the rest of the time. So, all right. In the figure below, the lengths of the sides of the right triangle BAC are shown. BD bisects the side AC. So it's breaking this up into 2 equal pieces. What is the length of DC? There are 2 ways to get a correct answer. One of them is easier than the other, but I want you to give it your best shot. This is a problem 55, so it's one of the more challenging problems on an ACT test, but it is very doable. To make it more real, I'm going to give you the options. Right. Anyone need more time? Anyone feeling brave? What did you got? Just shout it out.
Is it 3?
Yes. Which triangle did you use to get it? Did you go the big way or the little way?
I used the one on the left.
Okay, the little one? I would do that one too. Again, because you've got that memory device. If I can convince you to memorize this yet, I will. 3, 4, 5 is a right triangle. It's the pattern. And so if we have 5 and we have 4, I'm looking for, hey, where's the 3? And it's going to be right here. And they told us that this was the bisector, or that it was the same on the 2 sides. If this is 3, guess what? So is this. And it's very quick. If you went the longer route that's a little bit harder, you would have to be saying, okay, 4 squared plus, I don't know, squared equals 2 square roots of 13 squared. And I want to talk about this just in case you get a problem that can't be solved a faster way. If you have to square something like this, the square is going to happen to the plain number. This becomes 4. But then the square root, this just becomes 4 times 13. And so if you ever have to deal with a square root in pieces like that, that's what's going to happen. The square happens to the normal number part. The square cancels out the square root part. And so you take 4 times 13, and then you divide by 16, and you'd end up with, or not divide, you'd subtract 16, sorry, losing track of things. And then you'd end up with 36. Square root that and get 6, but then you have to take half of it in order to get that piece. So, a lot faster to go for this way, possible to get the right answer either way. And again, if you don't feel comfortable simplifying roots, you can always run them through the calculator and work with the decimal equivalents. All right, I lied about Pythagorean theorem. We're not quite done yet. In the coordinate units, you have -3 and 5 and 4, -1. And the question is, what is the distance between those 2 points? You may have learned this with what's called the distance formula, but I find that one very hard to memorize. And so if you can mentally step back and remember it's just a Pythagorean theorem problem, your life is going to be easier. So, not seeing a lot of writing, does that mean you want help on this one? Okay. So, every distance formula breaks down into 2 things. If we're talking about the distance between 2 points, we're looking at the change in x. How far horizontally has it changed? From -3 to 4, how far apart are those? So we're looking at change in x equals 7. And then we are also looking at the change in y. How far up and down has it changed? Between 5 and -1, how far apart are they? And we only have to look at positive numbers. We're talking about the length. We're talking about distance. So from 5 to -1, how far apart are those?
6.
6. And so all you have to do, 7 squared plus 6 squared. And then take the square root of that. So, really quick check-in. Is there any greatest common factor between 7 and 6? No, so nothing's going to factor out. The whole thing is just under the square root. What do you get?
85.
And then our final answer is square root of 85.
1.2.
If you notice, I'll hold it up for the camera, they left it in that root. You just have the square root of 85. And the reason I emphasize that you make sure you got the square root is that they offer up 85 as a plain answer. Don't get trapped by that pitfall. But that's it. Distance formula, don't try and memorize the distance formula. That whole x2 minus x1, it's talking about how far apart are those 2 numbers. y2 minus y1, it's talking about how far apart are those 2 numbers. And so it's just a Pythagorean theorem problem. Distance formula is if you're talking to a machine, not a person. All right. Finally, we're getting to sine, cosine, and tangent. So again, like I said, they really, really like these. And so right off the bat, they're giving you one of those special right triangles, 5, 12, 13. And they're asking about the sine, cosine, and tangent. I don't know why I switched into capital letters, just came out. Do you have this memorized yet? Would have been at the end of geometry. It has something that sounds like a different language. The standard memorization is so, ka, toa. And again, before your final, this is the ACT run that I really care about, this is the one I'm going to submit to all the colleges and I want to be really proud of, have this memorized. It stands for the sine relationship is the opposite over the hypotenuse. The cosine relationship is the adjacent over the hypotenuse. And the tangent relationship is the opposite over the adjacent. So, the first question I'm going to ask you is, which one's the hypotenuse?
13.
The longest one, 13. This is what's called a constant. It's always the hypotenuse, does not change on you. But if I ask you which one is the opposite, your brain should be kicking in with the question of opposite to what? Opposite and adjacent are called relative terms. They have to be in comparison to something. And so here, we won't just be talking about sine, cosine, or tangent. Those don't exist in a vacuum. They're going to be the sine of A, the cosine of A, the tangent of A. And A is specifically talking about the angle at the point A. And so sine, cosine, and tangent have to be in comparison to, this is the starting point, or the place you're looking from. And so now, if we look at A, hypotenuse is already taken. Hypotenuse is hypotenuse. And so this opposite and adjacent is talking about the opposite leg and the adjacent leg. They're talking about the two shorter sides of the triangle. So opposite is straight across. It's not touching the angle, it's across from the angle. And so this 12 is our opposite side. Versus adjacent is attached. It's part of the angle. It's helping make up the angle. And so our adjacent is 5. So hypotenuse is always hypotenuse. Opposite and adjacent are in comparison to the angle they gave us. And so for our sine, opposite over hypotenuse, we're looking at 12 over 13. That's going to be our sine. Our cosine, adjacent over hypotenuse, we're going to be looking 5 over 13. Our tangent, being opposite over adjacent, tangent is going to be 12 over 5. And so when we talk about sine, cosine, and tangent, they're talking about which piece compared to which piece. Now, sine and cosine are going to be restricted to being less than 1 because the hypotenuse is always the biggest side. Biggest side is on the bottom of our fraction. It has to be less than 1. Tangent can be all over the place because it's just comparing the two sides, and they could be something very different. Now, what happens if we compare it to the other angle? If we talk about the sine of B, the cosine of B, the tangent of B. Hypotenuse is still hypotenuse. That doesn't change at all. But if we change our point of reference, and we're starting from this angle, now our opposite is 5, and our adjacent is the 12. And so if we change where we start from or where we're looking in reference to, completely changes what you're going to use with this. So write out sine, cosine, and tangent from the perspective of B. So not as common with the ACT. I could see it showing up, but I can't guarantee that it will show up. One of the common relationships is the fact that the two angles have this matching relationship with each other. The sine of A is the same as the cosine of B. The cosine of A is the same as the sine of B. And so be aware of that relationship. I don't guarantee that you'll need it, but it's just something good to notice. So on the particular test question that we actually have, they give you the triangle with the 3 measurements, and then they give you 5 options that show you, and they just ask which one of these is possible. And so we've got f cosine of A is 12 over 13, sine of A is 12 over 13, tangent of A is 12 over 13, cosine of A is 13 over 5, sine A is 13 over 12. So the first thing I'm looking for is, okay, we're definitely working with A here. And so again, I'm looking at, this is my opposite A, this is my adjacent to A. And so again, that frame of reference is very important. The next one is, all of them are asking about 12 and 13. And so we're very clearly looking at opposite and hypotenuse, because those are the 12 and the 13. And then the relationship that works is that our sine is 12 over 13. Anything with the 12 on the bottom can get X'd out, because we're never working with the hypotenuse down there. You will later on. They have inverse ones, but you aren't working with that so much. So that's it. A lot of these went difficult, so we're going to work with it, but understand that the problems that I had are a little bit more difficult than what you'll see. So a right triangle, out of curiosity, standard naming, if you have A as the vertex or the corner, little a is the side across from it. If you have B, little b is the side across from it. If you have C, little c is the side across from it. That's just a standard math form thing. The question is that they ask you to find the tangent of A and the sine of B. And you're just going to leave that as a fraction with variables. So write it as in terms of fractions with variables. What is the tangent of A and the sine of B? All right. So again, going back to the roots, where's the hypotenuse?
C.
Yeah. So, on our first one, we're talking about the tangent of A. Tangent is opposite over adjacent. So what is opposite A? Yes. A. And then adjacent, the other one, we already said that was the hypotenuse, so B's left. Now, for the sine of B, we're changing our reference point. What is opposite B?
B.
Little b. And then over hypotenuse, hypotenuse is always C. So the actual question asks for the product of these two things. They ask us to multiply tangent A and sine B. And so that's why I had you find them individually first. We're just going to multiply A over B times B over C. What does that come out to? Dust off your multiplying fractions. How do you multiply fractions?
The two B's cancel out, and your final answer is A over C.
Yes. Cross-reducing. If you have the same number top and bottom, it's like it divides itself, turns into a big fat 1, and you don't have to worry about it anymore. And so we just have A over C. And that is one of our offered answers. In fact, it's the first one. Letter F up at the top. So that is trigonometry. So they tend to lean into the conceptual. There are certain solving ones, but they are less common. So let's talk about how to do that if they ask you to. So let's say that they've said to find angle B. How would we do that? In this particular case, they've given us all three numbers, and so you kind of pick your favorite. A lot of people stick with sine because it is the first one. Some people like to stick with tangent because they like that one. Doesn't matter. But I'm going to stick with sine. So if we look at B, what is the sine of B? Yep, so our opposite and adjacents flip again. We're looking at 13 over, no, sorry. So we're looking at opposite B. What's opposite? 5 over hypotenuse 13. So, again, here's the difference between what you might have done in the past versus what you're going to see on the ACT. In the past, you would use your calculator and you would type in sine inverse, or the second key, the sine button, and then you would do the second key's inverse, or the sine inverse of that 5 over 13, and you'd get an answer. But on the ACT, they're going to offer it up to you like that. You're going to leave it in that form just like you leave a lot of your answers in a square root. It will show up in your multiple choices as sine -1 or sine inverse of 5/13. And so they very, very rarely have you calculate out. If they do, they give you the decimal equivalent to use so that it's still possible to do longhand even though it's kind of annoying. And so in general, they do not ask you to calculate anything that is impossible to do by hand, but it is faster with the calculator. So that is what you would do. The same way, you may be given a problem where you have this angle is 27 degrees and this side length is 5, and they ask you to find height. So again, where's the hypotenuse? That's always going to be your first question with a trig problem. 5. And since we know that it's 5, we know we have the hypotenuse. That rules out tangent. We're not going to be using tangent. Compared to 27, is h opposite or adjacent to that 27? Opposite. And so we're going to be using sine. We're going to be using the one that uses opposite and hypotenuse. We're going to use the one that works with what we have. So we would say that the sine of 27 equals opposite over hypotenuse h over 27. No, sorry, not 27, 5. Lost track of numbers for a second. And so we set it up just like we have been with the other problems. How would we solve for h? How do we get rid of that 5?
Multiply 5 on both sides.
Yeah, here it would cancel. Here it would come out as part of our answer. So again, on the ACT, frequently they would leave that as your answer. You would just have 5 sine 27 as the answer. Go ahead and type that into the calculator. What answer are you getting? Sure.
4.78.
4.78?
Yeah.
That seems big. Does anybody have something different?
0.45.
Okay, I'm going to look at both of yours and see. Okay. So, what's going on with yours is if you go into mode, you want to make sure that your mode is in degrees. So that's why I had, it should be 0.4 something. It was rather small, and that's because 27 is a very small angle. But if you're getting 4 point something, your calculator is in radians rather than degrees. You're going to have to switch it and the mode. The reason for that is it's the difference between measuring in inches or feet. It's a very different scale. Well, closer to the difference between inches and meters, but if your calculator is in radians, it will give you a wrong answer. Unless they tell you differently, in general, ACT is working in degrees. It's another reason why they leave their answers like that, is to eliminate that calculator error. And so make sure that you are in the right units if you have questions about how to switch that.
I got 2.6 and I switched it to degrees, so 2.6.
That sounds right. So when you did the sine, did you multiply by 5 or did you just take sine of 27?
5 to 27.
Yeah, so with the times 5, that does work. All right. So we've done that one. Don't need that. We'll do that one last. Okay, we're going to talk about this one. It's another case of the ACT might throw something at you that you haven't seen before, but you can find it with a little bit of background. And so I'm just going to show you that background so you're not intimidated by it. So you've done coordinate plane graphing. And you understand that this is the positive direction. If you have a positive x and a positive y, you end up in the first quadrant. If you have a negative x and a positive y, you end up over here in quadrant 2. If you have negative and negative, you end up in quadrant 3. You've got negative both directions. If you go positive to the right but then down, you end up in this quadrant. And so that's stuff that you've dealt with before. The question is, for an angle whose measure is in between 90 and 180, what we're looking at is this is 90 degrees, and then 90 to 180 is right here. We're looking in this quadrant. And they're telling you that the tangent of this angle is going to be -7/24. What's going on is tangent is opposite over adjacent. So we are specifically looking at this angle right here. Opposite is going to be 7, and adjacent is the -24, because it's negative in the x direction, positive in the y direction. So that's just a little bit of setup. And the question is, which of the following equals the sine of theta? Oh, not squared. So, in order to find the sine, what two pieces of information do we need? Yeah. Yeah, we need the opposite and the hypotenuse. We've already got the opposite, so we've got to find that hypotenuse. And this is why I did the this is why I did the Pythagorean theorem with sine, cosine, and tangent. They tend to overlap a lot. They'll give you one and then ask you to find the other one. You've got to find that third side in order to be able to write our answer. So, again, what's -24 times -24 going to be? Positive or negative?
Positive.
Positive. Anytime you've got these squares, they're going to come out positive. And so to eliminate the chance of making a mistake with your calculator, you have two options. To know that it's going to be a positive number, it's going to be a distance, and just type in 24 squared, or to be very parenthesis happy, and in your calculator type -24 squared. Because one of the most common mistakes with the calculator is to write -24 squared plus 7 squared. If you do that, you're going to end up with a wrong answer. And so you can intuitively know, hey, I'm dropping that sign because I'm dealing with lengths and just do 24 squared, or make sure you put it inside parentheses so that the negative sign is also getting squared. Either one of those is great, but just be sure that you're doing it, because otherwise the negative sign will throw you. What do you get?
648 when you add 72.
Not 72. What's 7 times 7? 49. So 24 squared plus 7 squared. What do you got? I don't have a calculator on me, but that sounds right. I knew it should end in 5. So this equals the square root of 625. What's the square root of 625? 25. It's another one of those Pythagorean triples that the ACT likes. It works out to a nice, pretty number. They're very fond of them. And so our sign is going to be positive 7 because it's above, it's in the positive y direction. We have positive 7, and then the hypotenuse is always positive 25. And that is our sign. That one was a question 58. Again, it's very near the end of the test, a little bit trickier, but I wanted to talk about it because it's good to talk about, well, we know these two, find out what the third one is. The negative sign, more of a curveball, and usually it would have just given you positive 7 and 24 and asked you to find the sign. And so that's more the speed I would expect to see. I just grabbed this one because it was really close and good to talk about. All right, we are ready for a break. Take it, stretch, get a drink, all good things.